God. The graph shows the relationship between the area of lawn that is cut and the time needed to cut that area.
We need to calculate the rate of change. Again, rate of change is rise over run. So this time you need to really pay attention to the scale. Let's draw a rate triangle. Okay, everyone draw your rate triangle. Rise over, oops. Oh shoot. Run. So you went like this?
Yeah.
That's fine. Rise over run. I mean run, okay, that's fine. Rise over run. Danica. Now they've given you the coordinate. What does this line rise by? I would not count 1, 2, and so on because the scale is not counting by ones. It goes from 0 up to what? Look at the coordinate they give you. Where does it end?
350.
3, look at the coordinate.
350.
330. Look at the coordinate of the point. It's located at 22 and 330. Specifically, it looks like it's 350, but it's not, okay? So the rise is 330, and what is the run? It goes from 0 to what? 22. 0 to 22. It has a run of 22. We're gonna simplify that. 330 divided by 22 equals 15. Okay, so we're trying to figure out what it means in this context. The rate of change is 15 over 1, right? 15 over 1. So what that means is that it increases. If the area is 15, so what that means is that 15 meters squared for every 1 minute. So for every minute, they are cutting 15 meters squared of grass. That's what that means. Okay?
Is that a minute?
Per minute, yes. 15 meters squared per 1 minute. They cover 330 meters squared in 22 minutes, so it's 15 meters squared in 1 minute. Okay? So now that we know that it's 15 meters squared in 1 minute, how would you calculate how much area they would cover in 45 minutes? Pardon, Jen? 15 times 45. Good. Calculate. Good. 675 meters squared. Now let's do the opposite. Shh. How long will it take to cut 1,350 meters squared? It's 15 minutes for 1 meter squared. So what would we do to figure out how many minutes it is for 1,350 meters squared? Good, divide. Divided by 15 equals 90 minutes. How many minutes are in an hour, Maurice?
60.
60 minutes. So what is that, an hour and 30 minutes, an hour and a half. We could say 1.5 hours. Gajani calculates the rate of change during 3 intervals and finds that in all 3 cases the rate of change is the same. She concludes that the rate of change between any 2 points on the graph would be the same. Is she correct? Yes or no?
Yeah.
So you're trying to calculate the rate of change. You're drawing 3 different triangles, basically. Okay, so look here. You don't have to draw the same triangles, but maybe I want to find the rate of change between this point, and I'm just going to pick a random point, this one. So I'm going to find the rise over run for that. Then I'll choose this one. Let me choose a different color. I'm going to calculate the rise and run for this point, and let's do this point. Actually, no, I'm not going to do that one. Hold on. I'm going to do this one. Rise, over run, and then I'm going to do the whole thing. Let's do this and this. Rise, over run. So I'm color-coded them. Let's do the first one, purple. Rise, over run. It goes up by 5, right? It's a scale of 5, 10, 15, over, what's my run? 1, 2, 3. Okay, I got 15 over 3. What's 15 divided by 3? 5. Okay, let's do the next one. Pink. I chose this point and this point. So rise would be 5, 10, 15, 20. Over. Am I counting by 5s or 1s for the run? 1, 2, 3, 4. What's 20 divided by 4? What are you noticing?
5.
The last 2 points I chose were this one and this one. I'm going to count the rise. 5, 10, 15, 20, 25, 30. Over. 1, 2, 3, 4, 5, 6. What's 30 divided by 6? So I picked any 2 random points to find the rate of change. Gajani is saying that it doesn't matter which 2 points you choose, the rate of change will always be the same. Do you agree?
Yes.
Yes, because why? It's a straight line. The rate of change can't be different if the line is increasing by the same amount every single time. The line is straight, which means the rate of change is constant. It does not change on a straight line, okay? So write that down.